Alright, so in this video we're going to go over muscles. And so we're going to go over specifically skeletal muscles. And so there's a lot to cover, so I might do it in 2 videos, but I might do it in 1. We'll see how much I can bear. But I think what I'm going to start with is cross-bridge cycling. And this is like the last step of muscle contraction, but I think it makes sense to just go over it first, because it just tells you everything about like what builds a muscle, like everything. So the unit for muscle is like a sarcomere, and so it's built with actin, myosin, troponin, and tropomyosin. And so this is kind of what a sarcomere is going to look like. Obviously this is just like a kind of small representation, but what we have in red is myosin, and what we have in blue is actin. So anywhere where there's an intersection between the myosin and the actin, that's called a cross bridge. So right here, and then right here where there's not an intersection between actin and myosin, is just not a cross bridge. So that's good. Like, that's something to keep note of for later. But like, if we want to like understand it, we actually have to look even deeper than that and see what's going on. So basically, what's going on is, I'm going to try to keep color coordination, is this is actin, this is going to be myosin, it's going to be a little more down actually, a little more myosin, and then I'm going to start drawing troponin and tropomyosin now. So I guess tropomyosin will look like this, and troponin will look like this. Now, what does this mean? So this is at a relaxed state. Your muscles are not ready to contract at all right now, but and then I'm going to show you a contract state. So then, just so like I can show you and compare. So it's going to be the same thing, kind of three loops. And now we have this. Alright, so now this is the, I guess, active state, or like being ready to contract. So what is going on here? I'll move this down. So what is going on here? So basically, in the relaxed state, you have tropomyosin in the purple here. I'm going to label it tropomyosin, and this is troponin. And so basically what's going on is tropomyosin is blocking actin so that it cannot contract. It's not ready to be contracted. However, and troponin, what troponin does is it's going to pull the tropomyosin outwards, and this is what you see here, where you have troponin is going to pull the tropomyosin, and now it's ready to contract. So what's going on is tropomyosin is stopping the contraction basically. And so in order to be ready to contract, troponin needs to pull it. And so what's letting it pull it? It's calcium. This is calcium, and calcium is letting it pull. And so now, because of that, myosin can bind onto actin. You see here where it's not connected, and here where it is connected, here where it is connected, and here is not connected. Now it's binding. It's going to be ready to do what's called a power stroke. And so what's going to do is, so this is like the normal thing, and then it's kind of, I suck at drawing. But what's going to do is, this is going to come this way. So it's going to look like, I guess, kind of like a heart. It's like that way. So it's going to go that way, and it's going to pull the actin that way. So this is called the power stroke. And if we want to look even deeper, this is what's going on. So step 1, calcium comes in. And allows for the cross-bridge cycling. So I guess it's like not even step 1, this is step 0. So then step 1 is ADP comes in onto myosin. Step 2, myosin binds to actin. 3, ATP comes comes in, and then there's the power stroke, and then ATP comes in to disconnects myosin and actin, and then step 4 is ATP turns to ADP and P. This is called hydrolysis. And so this is basically what it looks like. So here's like a more visual representation. So ADP and P come in, and then that'll allow this myosin to bind. Upwards, and throughout this time, the tropomyosin's coming off. Before then, so now we're on step 1. So ADP and P comes in. Now they're active. Now this will do the power stroke, so it'll flip this way, and then this comes off, and then ATP comes in. Making this dissociate, and then once this dissociates, this will turn to ADP and phosphate, and then because of the cycle, it'll go straight back to this. And so what's going on is this right here is the rate limiting step. So you are limited by how fast you can do this. That's important to know for other things, but this is basically what cross-bridge cycling is. Alright, and now let's now let's start from the beginning of, I guess, muscle contraction. So we're going to draw like normal a neuron, and then you're going to have the muscle cell. And so, same stuff, action potential, voltage gated calcium channel. Let's add in ACH, which is acetylcholine. Acetylcholine comes out, ACH. So ACH is now in the neuromuscular junction. Muscular junction. And so now it's going to bind onto a receptor called the nicotinic receptor. On the muscle end plate. So this isn't really the muscle, is the muscle end plate. On the muscle end plate. Let's switch some colors. And this will allow for a Na plus influx, which will lead to a local potential within the end plate. And then once the local potentials add up, it's going to create an action potential within the end plate, and then it's going to travel down to this little hole in the purple here. And so what this is going to do, let's draw it in green now. You have a receptor here called the DHP receptor. And what that's going to do is the action potential is going to come down from all the local potentials that are coming from the nicotinic receptors from the Na influx. And so it's going to activate the DHP receptor, which is going to talk to a part of the cell called the sarcoplasmic reticulum. So it's going to talk to this, and it's going to interact with something called the ryanodine receptor. And well, this is kind of a misleading name because it's not a receptor, it's really just sending stuff out. And so what the sarcoplasmic reticulum is, it's the storage for calcium. And then calcium is going to come out to through the ryanodine receptor, and it's going to activate the myosin and actin. So, and then you're going to have the cross-bridge cycling. And so then once you have, I guess once you're done with contracting, here's what's going to happen. You're going to have acetylcholinesterase, acetylcholinesterase, is going to break down this and this, acetylcholine. And so acetylcholinesterase, what that's going to do is going to break it down, and it's not like reuptake, so it's not going to go into here. It's legit going to die. It's going to be broken down to more usable pieces, right? And so that's what's going on in the synaptic cleft. Oh, I guess before then there's also no more action potential. So no more action potential, and then ACHE is going to do its thing. After that, calcium release stops. I'll do that in another color. Calcium release stops, and then there's another pump here called the calcium ATPase pump. And the calcium ATPase pump, what that's going to do is it's going to use ATP to bring back the leftover calcium into the sarcoplasmic reticulum. So if this is a storage, the sarcoplasmic reticulum is a storage cell for the calcium, you're going against the gradient, so you need ATP to bring back the calcium into the sarcoplasmic reticulum. And so yeah, I just went through the entirety of muscle contraction. So basically, let's slow that down, okay? Step 1, AP. Step 2, AP, calcium, and then ACH release. Normal stuff. Step 2, excitation. Wow, I cannot spell. Excitation. Something like that, sure. ACH release, ACH goes to receptor, which goes to which leads to Na influx in the end plate, and so the depolarization leads to graded potentials or local potentials, and so that's going to lead to an action potential in the muscle cell, which is step 3. So this is the excitation part. And then there's the coupling. So then moving on from here, the AP, step 1 AP goes to the DHP receptor, which then talks to sarcoplasmic reticulum, or the SR, which will then cause it to release calcium through the ryanodine receptor. And so then cross-bridge cycling. So it leads to cross-bridge cycling, and then once you're done with contraction or relaxation, what's going to happen is, step 1 is no more action potential from neuron to acetylcholinesterase, ACHE, breaks down ACH, 3 CA 2 plus ATPase pump, And that's it. That is the entire, I guess, muscle system. I'll go back. I'll make a second video on like what does this mean type stuff, and like how to really like apply it, because there's a lot more that goes into muscles, but this is the general gist of it. And yeah, thank you for watching.